Hello, boys and girls. Today we're going to be looking at expressions and reviewing expressions for the final exam. And this is also a topic that comes up a lot in 7th grade, so this is going to be good practice for 7th grade as well. So make sure you're at the page that says Unit 4 Expressions. Now, before we try these out, and these might look familiar, we're going to evaluate these expressions. We first want to remember the cheer that we've been using to evaluate these. Parentheses, powers and roots, multiplication and division from left to right. Lowly, addition and subtraction from left to right. So while you're evaluating expressions, you always want to have that in mind. It will help lead you through it and make sure that you're finding the correct answer. Now, the first one's kind of different because it's just dividing. And it's also dividing fractions. So what we're going to do is actually keep, change, flip, because that's what we would use when we divide fractions. So even though we just did the cheer, since this one's really only one step, the division, we're not necessarily going to do the whole cheer for this one. So let's see here. We're going to keep, change, flip. But first we need to change that 40 into a fraction, 40 over 1. And then we will keep, change, flip. So it's going to be 40 over 1 times 8/5. Now, once we have this, we want to think, can we simplify? Well, if we look diagonally, 1 and 8, you can't do anything. 40 and 5, though, we can divide both by 5. 40 divided by 5 is 8. 5 divided by 5 is 1. 8 times 8 is 64 over 1, which is just 64. The next one's kind of a straightforward expression too. This is a whole number multiplied by a fraction. We're also going to write that 15 is 15 over 1, like a fraction. Now we will not have to keep, change, flip here because this is not division, this is multiplying. So we're just going to multiply it. We're going to look diagonally to see if we can simplify. 4 and 1, we can't do anything, but 15 and 5, we can divide by 5. 15 divided by 5 is 3. 5 divided by 5 is 1. 3 times 4 is 12. 1 times 1 is 1. 12 divided by 1 is 12. So that one's even more straightforward because we didn't have that extra keep, change, flip step. All right, the next one, we're going to have to use the cheer here. First, I'm going to rewrite it. It's going to be step 1. And then we'll look for parentheses. Now, there's no parentheses. So then powers and roots. Well, I see a power here. 3 to the 4th power, which means 3 times 3 times 3 times 3, which is, I'm going to kind of do an upside down squiggle here. That's 9 times 9, which is 81. So I'm going to rewrite the whole thing, but instead of 3 to the 4th power, we're going to have 81. Then I'm going to start the cheer over again. Parentheses, no. Powers and roots, no. Multiplication and division from left to right. So I start from the left, and I see I have multiplication. 20 times 81. You'll have a calculator again, but it's important to show the steps. 20 times 80 is 1,600, so 20 times 81 is 1,620, plus 15 divided by 3. Parentheses, no. Powers and roots, no. Multiplication and division. We see division here. It's the only thing left besides the addition. So we have 1620 plus 15 divided by 3 is 5. 1620 plus 5 is 1625. Okay, let's try the next one. First step is we're going to rewrite it. 5 squared times 4 plus 5. So let's look first for parentheses. We see there is a parenthesis. We'll do that first. 4 plus 5 is 9. So we have 5 squared times 9. Parentheses, nope. Powers and roots, yep. We have a 5 squared, which means 5 times 5, which is 25. 25 times 9. And that's our last step there. Well, 8 quarters I know is $2, so 9 quarters would be $2.25 or $2.25. So that wasn't too bad. Let's try the next one here. 5 minus 3 plus 4 cubed times 2. Parentheses? Yep. We have a parentheses here. We're going to do that first. 5 minus 3 is 2 plus 4 cubed times 2. Parentheses? Nope. Powers and roots? Yes. 4 cubed, which is 4 times 4 times 4. 4 times 4 is 16, times 4 is 64. So we have 2 plus 64 times 2. Parentheses, nope. Powers and roots, nope. Multiplication and division. Yes, we do have multiplication here. 64 times 2 is 128. Plus 2 is 130. All right, last one here. 3 times 4. Make sure to not write that as a decimal point, that little dot there. That's the multiplication symbol, multiplication dot. Divided by 2, all right. Parentheses, yes, we do have parentheses. 14 minus 8 would be 6. So we're going to rewrite everything. We don't need the parentheses anymore because there's only one number left in there. Divided by 2. Parentheses gone. Powers and roots? Nope. Multiplication and division from left to right. So I'm starting at the left here. Whatever I see first, I'm going to do with multiplication or division. So I see multiplication first. 3 times 4 is 12. Plus 6 divided by 2. We'll do the division next. 6 divided by 2 is 3. 12 plus 3 is 15. Morning. So here's our answers here. Okie dokes. All right, so what we're going to look at now is somewhat similar. We're going to be simplifying, actually, and somewhat unsimplifying here. So in this example, we have a variable. And what we're going to do is, since we know what the variable is 4, anytime we see n, we're going to substitute in a 4. Now we have to be really careful because that 3n does not mean like just put the 4 there and make it 34. It means 3 times n. So when we rewrite this, we're going to have to put a multiplication symbol between the 3 and the n. So 3 times n divided by 4. Okay. Whoop, forgot to substitute the n there. There we go. All right, so what do we do first? Parentheses. We look in the parentheses, we see there's adding and there's an exponent, so we'll have to do the exponent first. So it's going to be 4 squared, which is 16. So 4 plus 16 minus 3 times 4 divided by 4. We still have parentheses because I didn't do everything in the parentheses, I just did the exponent. So we'll have to do the parentheses again. 4 plus 16 is 20 minus 3 times 4 divided by 4. Parentheses are gone. Powers and roots? Nope. We did those already. Multiplication and division from left to right. So I'm going to start from the left. So whatever I see first, which is going to be the multiplication. So we'll do 20 minus 12 divided by 4. Then we have the division to go. 20 minus 3, which is 17. Okay, the next couple here are actually simplifying. And when we simplify with an algebraic expression, we can only combine what are called like terms. So here we have 5x's and an x, and 7y's and 3y's. We can only combine together the variables that are the same. So I'm going to circle the x's in red. I'm going to circle the y's in blue. We can combine the x's. 5x's plus another x is 6x's, plus 7y's and 3y's would be 10y's. So that's a plus sign there. So that's the simplified version of that expression. Has the same value, just combining like terms. And if we look at this one, we have 12x's, 4x's, 2y's, a y, and another y. So how many total x's do we have? We have 12 x's and then 4, which would be 16 x's, plus 2 y's, plus another y is 3 y's, plus another y is 4 y's. So that's the simplified version of that expression. All right, factoring we've done quite a bit on Throwback Thursday, so this should be familiar. We have 15x and we have 40. What we're going to do is we're going to use the factor trees. We're going to break these numbers down and then we're going to factor them. All right, so we have an x. We can't break that down, so we're going to circle it. 15 is going to be 5 times 3. Can't break those down, so we'll circle those. 40 can be 5 times 8. Circle the 5. 8 might be 4 times 2. Circle the 2. And then 4 would be 2 times 2. So let's see what they have in common. They have a 5. So that's going to be the GCF. That's the only number they have in common. Parentheses. Let's see what's left over on each side. So we have 3 times x on this side. That's what's left over. So it's going to be 3x. Plus 2 times 2 times 2, which is 8. Now to check that, just to make sure we got it right, we can use the distributive property. 5 times 3x is 15x. 5 times 8 is 40. All right, we're going to try the next one. It's very similar. In fact, it's the same idea, but different numbers. So we have 8x and 12. All right, so we'll break these down. We'll find the factored form. Here we go. So we'll circle the x, break the 8 down into 4 times 2. Circle the 2, break the 4 down into 2 times 2. Can't break that down anymore. 12 might be 6 times 2. Circle the 2. 6 might be 3 times 2. All right, so let's see what they have in common. They have a 2, and they have another 2. And 2 times 2 is 4. So that means to start our answer, our GCF is 4. That's going to be outside the parentheses. 4 groups of 2x, that's what's left over, plus what's left over here is 3. And that's it. Let's check that real quick. 4 times 2x, 8x. 4 times 3 is 12. All right, let's check out the next page here. We're going to translate these expressions from words to symbols. Okay. 5 more than 4 times n. So we have 2 math words in there, kind of. We have times, which is multiply. We have more, which is add. 5 more than 4 times n. Well, I like to start with the variable usually. So I have n here. So we need 4 times n. And how do I show 4 more than that? We'll add, 5 more than that, we'll add on 5. And that's it. So the key thing, I like to start with the variable and then work my way up from there. That's, I think, probably the best method to use to get the answer here. 10 less than 5 times g. We'll start with g. What are we doing to g? It's 5 times g. And then we want 10 less than that. So this is a tricky one because a lot of people like to put the 10 first, but we're taking 5 away, or 10 away from 5g. So we need to subtract 10 at the end. So even though the 10 is at the beginning, we're subtracting the 10 at the end. This one's kind of similar. So 4 less than 3 plus w, we have that plus, which is adding. We have that less, which is subtraction. So I'm going to start with the 3 plus w, or the w actually. So 3 plus w, and then 4 less than that. I might even put that in parentheses and say, I'm going to do that first, and then I want to find 4 less than that, so I'm going to subtract 4 at the end. So even though 4 is at the beginning, we're subtracting it at the end because we want 4 less than 3 plus w. Okay, the sum. So sum is adding, times is multiplying, and the and kind of means that that's where the adding is going to happen. So the sum of 6 times f and 7, we'll start with the variable. We want 6 times f. and the sum of 6 times f and 7, so we're going to add 7 to that. Okay. So those might like kind of seem simple, but you just got to be careful with the ones that have like 4 less or 10 less. And my clue or my hint or my tip would be to start with the variable. That might help you write the expression. All right, the last couple of problems are also expressions. We're going to be writing some numeric expressions, so no variables in these. It says the Bisons charge $12 for an adult ticket, $7.50 for a children's ticket. Write an expression to show the total cost of buying 3 adult tickets and 7 children tickets, should say tickets. All right, so we're going to write an expression for this. And that expression might be, well, it's $12 for an adult ticket, and we are buying 3 of those. So 12 times 3 plus, it's $7.50 for a children's ticket, and we're buying 7 of those. So there's our expression, and then to evaluate it, we would do 12 times 3, which is 36, plus whatever 750 times 7. Well, I know that 7 times 7 is 49, and then a half of 7 is 350. So 49 plus 350 would be 5250. Again, you'll have the calculator, but you still want to show the steps here. Plus 36, which would be 36 plus 52 would be 88, and then 50 cents would be 88.50. Nice. All right, last one. The Bills charge $50 for an adult ticket and $21.50 for a children's ticket. Right? The expression to show the total cost of buying 4 adult tickets and 2 children's tickets. Okay. So $50 for an adult ticket. How many of those are we buying? We're buying 4. Plus $21.50 for the children's ticket, and we're buying 2 of those. So there's our expression for adult tickets, 2 children's tickets, and let's evaluate it. 50 times 4 is 200, plus $21.50 times 2. Well, 21 times 2 is 42. 50 cents times 2 is $1, so it'd be 42 plus $1, which would be 43 bucks. Plus 43. And our answer is $243. It's kind of expensive, but you know what? It might be worth it. All right. So those are expressions. If you have any questions, please let me know. I hope you have a great day, and I hope to see you soon. Bye-bye.